They are one of the destructive insects affecting farmers across the globe. They are tiny but a powerful army of insects. Fall armyworms invasion into Ghana some 8 years ago remains elusive to scientists. They are causing financial losses to farmers in the maize, rice and sorghum industries. Their treatment is also a real struggle for scientists. Fortunately, in today's episode of The Food Chain, we interact with some scientists at the Crops Research Institute of the Council for Scientific and Industrial Research who have come up with biological means which are less harmful to the environment to fight this particular insect. My name is Emmanuel Bright-Kweku. Join me.
Okay.
Farmers anxious at what could have been a sight they would have preferred to behold on their farms, a well-matured pest-free maize farm. For years, maize farmers across Ghana and by extension the African continent have had to battle a common enemy on their farms, the fall armyworms. Striped grayish-green caterpillars with dark brown to black heads, the invasive pest has a strong preference for feeding on grasses, especially of maize, rice, sorghum and other crops. Kwame Kobi and his wife, Efia, are farmers in the Abrankese community in the Bosomtwe district of the Ashanti region.
Poison no cry to go have a bomb prinum prensa. And Sana bia Timia Kumo Kakra and Crane Comunina, Vicum Kakra, Kakrakano. It was an answer Bruno, Kakra Yina, when you be a chat. Inti Ohano de his son or higher, papa, his son or higher. You can be a fast so I bit must go poison. Ubo we are Sasta, Ubo and Timinco, Mubu and Timinco. Poison Bacubina and a boy cry, Omo friend Krupa. And no, track it to a be. No craft with the tobacco 500 woody bomb, Cacrebina, asa. I don't know, it me, a mamuano, a broman was cacra.
The couple are incurring losses after their farm is consistently attacked by the pests.
Just a old time running we are. Will a woman so much more? And to what time we are now, we are now, we are in Nano. If you are about no sem, nobody be a guinchay. No, I can't say Bruno, more woman to 20 so. Inti bo okra na wato no be 10 million e bo ko be ma be 7 million fi se de go no ontimi nya no hwe e ma ne nyeyi
san se adwuma bie ni fa me ye kan ho nti no ya na what eti fi se senkere bia sable ni sika wo ho aka betumi aboma e bia wo ma no ablase ba se ni wonti wo membe bu kakra se ye nipa fi se wo ye adwuma na se adwuma na wo fi se di esi ye no impuntio no enimu sa wo membe bu na so no eno ana wo ye uja ye kwata wunya duane eni One or the other. Indeed, your cosso say more sending in ano. Yes, you before say, and say, but Bodrono. Say the bay albino be a free moon, also the atodianidi.
The insect lays its eggs on the plant leaf, which grows into a larvae to feed on the well of the host plants. The migration of the pest, originally native to the tropical and subtropical regions of the Americas, remains elusive to scientists. It has rapidly invaded 47 African countries and 18 Asian countries since the first detection of invasion into Nigeria and Ghana in 2016. Dr. Kofi Frimpong Enin is an entomologist at the Crops Research Institute of the Council for Scientific and Industrial Research.
We're still not been able to identify the exact way they entered. Many have argued it is not possible for it to have crossed the Atlantic from the Americas to Africa. So the speculation is that it might have come through trade, a possible contaminated product that was sent from that part of the world to Africa. If we look at our climatic conditions, it favors the fall armyworm. It's a perfect condition for it. And when it came, we were trying to go through literature, and as I indicated earlier, you look at the lifespan, the number of days it would take the fall armyworm from the egg to the adult stage. You find out that when it came here, it has reduced a bit. For instance, in literature or in the Americas, they will tell you the egg would take about 5, 6, 7 days to hatch. But in Ghana here, I have personally recorded 3 days. So it means it's shortened about 3-4 days compared to other areas. So the conditions here are favorable, and they will continue to thrive until we find a permanent or a sustainable way of suppressing their population.
A 2017 research study estimated that maize yield losses in Africa due to fall armyworm would range between 8.3 to 20.6 million tons per year if management measures were not put in place. In Ghana alone, the value of the 2018 annual maize crop loss to fall armyworm was estimated at $177 million. The Bosomtwe district is well known for its cultivation of fresh maize for instant purchase after harvesting. But the district, located on the outskirts of the Ashanti regional capital, Kumasi, has since the invasion of the pests recorded dwindling production of corn. Eric Fofie is the district agric director.
Yield is quite good. For maize, they get around 2.5 to 3 metric tons per hectare on the average. So the yield is not bad at all. The major problem that is confronting farmers in this area, first is access to land, and then secondly is diseases and pests because of the continuous farming. And for that matter, they use chemicals, and this chemical affects some of the farmers. So when you come here, you see some of the farmers complaining all manner of sicknesses. Initially, when we experienced this outbreak, farmers were experiencing 50 to 100% losses of their crops. But with time, we introduce chemicals and some biological control materials as well. So the farmers can spray 2 to as many as 4 times before they harvest, and so it's a drudgery because they have to suffer a lot with the spray, and it's also costly. So the farmers complain a lot with the control of the fall armyworm.
Ridding of the insect has become a struggle for both scientists and farmers, with synthetic insecticides being the main treatment management since their detection. But this has been identified to have deleterious effects on the environment and humans, as well as the pests resisting the potency of the chemicals. Sean Ajiman is the Assistant Regional Extension Officer for Ashanti Region.
Some years back, when this fall armyworm really devastated our lands, there has always been a lot of researches to see how we can really control them. And currently, I think what most of the farmers are using is a chemical control, where they use a lot of chemicals, other type of them, to really control it. And we have all seen the effect of these chemicals in food, and that is why we always advise that it is better we see how we can use the biological control to really control it. So it's rampant. Every farmer that knows about fall armyworm has an idea of maybe applying this chemical or that chemical to control it.
The Crops Research Institute of the CSIR, with funding support from the Korea Africa Food and Agriculture Cooperation Initiative, is exploring the use of biological agents to fight the fall armyworms. 3 biological agents, including insects, fungi, and nematodes, otherwise known as soil worms, were adopted. Here are lead researchers for the various applications.
On our part, what we did was to survey the entire country to identify the various natural enemies that attack the fall armyworm. So in so doing, we were able to come out with a lot of them, but one of them stood out as more efficient in controlling the fall armyworm. In fact, we have other predators which capture the larvae or the caterpillar and feed on them. Some on the maize, some even on the soil. But these parasitoids are more efficient in a sense that they are able to destroy a lot of the fall armyworm eggs and by so doing, it means the caterpillar will not be formed. So even if they are formed, it's only the few eggs that are able to hatch that form the caterpillar that will destroy the maize. So we have this telenomous parasitoid, which lays its egg into the egg of the fall armyworm. So once the eggs are laid into that of the fall armyworm eggs, the fall armyworm eggs fails to hatch, and it will other way release a lot of the parasitoids. So in other words, the number of the parasitoids are going to increase while that of the fall armyworm is going to decrease, and by so doing, the infestation of the fall armyworm is going to decrease. In actual fact, we have a lot of these natural enemies, the telenomous, in the world, but we found out that the population is very low. So what we are currently doing is to boost their numbers in the lab and release them in the maize field. So in our trial here, our IPM strategy is you breed the telenomous or the parasitoid in the lab, and then after planting the maize, you release them so that they can attack the fall armyworm eggs at a very early stage, and by then you reduce your infestation. Right. The parasitoid egg has a very short duration. So when it lays its eggs into that of the fall armyworm, they turn into their larvae in the fall armyworm, and then they will eat the fall armyworm larva, and by that fall armyworm eggs, and by that they will destroy it, so it will fail to hatch. So before the fall armyworm larvae spend sometimes 3 to 7 days. In actual fact, it's supposed to be around 5, but we've identified that hatch within 3 days. So within that period, the egg that have been laid by the parasitoid will have hatched, and by that the fall armyworm larvae will not be formed at all. And also before it tassels, sometimes when you have large infestation of the fall armyworm, the caterpillar will cut the tassel. And once the tassel is cut, it means you are not going to be able to fertilize the ears that will form, and that you will not have good cobs on the maize. And even when the cobs are formed, we have seen a couple of times where the caterpillar also attack the cobs. So after harvest, you see that most of the cobs have been destroyed. So overall, if you're able to prevent the fall armyworm population reaching high that will destroy the leaves, you will have good yield. And when you prevent it from cutting the tassel, that means you also have another good yield. And when you prevent it from attacking the cobs, it means you have good yield. The quality is going to improve. Your aflatoxin levels are going to reduce, because once it is exposed, it's likely that you are going to have high aflatoxin infestation.
With our part of this work, we were using entomopathogenic fungi. You know, there are a lot of fungi in the system, or there are a lot of fungi that causes disease, or most diseases are caused by fungi. But, you know, we have the beneficial ones, which are a few selected ones that we had research on, and we know about their effect on insects. And when we talk about entomopathogenic fungi, basically they are fungi that infect and kill insects. So we wanted to use these beneficial microorganisms to fight the fall armyworm larvae. So what we did was we went to various locations in Ghana seeking for indigenous entomopathogenic fungi. So what we found was basically Bovaria bassiana, Metaisium, and Trichoderma. And these fungi, what they do is they attack the fall armyworm larvae by entering the cuticles. And when they enter the cuticle, they cause toxicity to the caterpillars. And most of the time, they release toxins into their system. And when they grow, they make the insects inactive. And with that, it cannot cause disease or it cannot cause damage to the fall armyworm, to the maize or to any other crop that is being infected with. So that's basically what we did. And we've researched thoroughly through in vitro labs experiments, and we also done greenhouse experiments and also with the field. And we've seen that the results are promising and it's very good, just like what we came to do here. So basically, that's what we did with the entomopathogenic fungi.
Okay. Now let's look at in terms of it affecting the cuticle. How does it do it? Can you explain?
Okay. We spray it just like we spray the normal insecticides using the knapsack sprayer, or sometimes we have the hand sprayers that we use, and we target the hulls of the maize plant. That's where the insects or the fall armyworm insect lives. And with the fall armyworm, the most destructive part is the caterpillar or the larvae stage. That's where the insects use the opportunity to eat and grow and turn into the moth or pupate and turn into the next stage. So when we spray it on it, it's a form of contact insecticide. When it gets into the body of the fall armyworm insect, the fungi is a spore, just like it's a spore, just like any other seed or like let's take be a seed. So when it enters into the cuticle of the fall armyworm larvae, it grows. It penetrates and it grows and it reproduces and it releases toxins into the system of the fall armyworm larvae. So by this, it makes the fall armyworm larvae or the insect or the caterpillar or whatever, it makes it inactive to do damage to the crop. So basically, that's how it works. And after some time, after it being introduced into the cuticle or the body of the fall armyworm, after its growth and everything, you see the spore also growing outside the body of the larvae, just like when I don't know how to use it, kenke or something like that, when it gets spoiled or when it gets fermented, that the fungi that grows on it is exactly that's how it does with the fall armyworm larvae.
Like the mold?
Yeah, it's a mold type, yeah. You know, molds are fungi.
Okay. Yeah. Now we are talking about molds. It affects the what is it? The maize. Yeah. Are you not sure does it have any effect on it? Posing some aflatoxins and all.
No. This kind of fungi, they don't produce aflatoxin to the maize. And most of the time, the work that it does, it finishes its work even before the maize gets the crops to turn into their yield for the seed to be manufactured or for the seeds to be brought up. So by the time that it finishes its work, it cannot go ahead to go and affect the grains or the crop. But basically, this EPF, it targets the larvae of the fall armyworm. That's the main thing. It's host specific. It doesn't affect any other thing. It targets the host insect that's going to affect it or that's going to do the damage. So it doesn't affect the maize crop or it doesn't release aflatoxin on the maize. That's not how it works.
The nematodes are found in the soil, but not in abundant quantities. So we searched throughout the country and we sampled a lot of soil. We brought them to the lab and we extracted the nematodes. So the nematodes, their mode of action is that when you apply them on the fall armyworm, you know the fall armyworm by nature it is the larvae that the larval stage that cause the destruction or that feed on the maize plant. So when you apply the nematode in solution to the fall armyworm, the nematode would enter the body of the fall armyworm through their natural openings. When I talk about natural openings, I mean the mouth part, the nose, the eyes, and any natural opening. And the nematode would take residence in the fall armyworm or the larvae of the fall armyworm and multiply. By way of multiplying, they will be feeding they will be feeding inside the fall armyworm, and by way of the feeding, they will kill it. So when the feeding resources in the larvae has gotten depleted, they will move out in search of another host to attack. It is there that we trap them and multiply them. So their mode of mechanism is they enter the larvae of the fall armyworm and kill it.
So the nematodes, can you give us specific ones you use though?
Yeah, the nematode, we use nematodes of two families. nematodes belonging to Heterorhabditidae families and then Stenotrophidae families. Nematode of 2 groups that we use, but it is in mixture. We are still working to do the separation, but what we applied is mixture of the 2 nematodes that we applied. The nematode, they don't have any negative effect on the soil. Just that this one, we applied them specifically to attack the fall armyworm, to kill it, so that the maize plant can do well.
There are calls for private collaborations to commercialize the project to reach farmers across the country. Professor Marian Quinn is the Deputy Director General of the Research Institute.
This is what we are also looking for, that the private sector in Ghana will come up and take up the responsibility to support such initiatives, so that the monies that would have gone for the importation of toxic chemicals for spraying the fields will go towards further research to improve more resilient systems, more resilient crops that are tolerant to the pests and the weather, for us to get enhanced productivity in our agri production.
And how would this ensure food security?
Food security is making sure there's food on the table all year round. There is economic empowerment. And this area is for women who are cropping the land 3 times in a year. We want to ensure that they adapt technologies that will ensure the productivity within the limited space that they are cropping. They have nowhere else to go. This is where they are farming. So all our technologies are ensuring that it's a holistic approach the CSI bring on board, taking care of the soil, of the water management, of the crop, and all these will go towards food sustainability, food security, ensure there's all year round production of the maize that they are cropping here.
In our quest to really ensure that food security is the topmost priority of the government, it is always good to see how we can minimize the residual chemicals in food. And this is why we intend to really focus on using the biological control to minimize the chemical residues in food. And this is why we all need to hold up to this kind of technologies like this, so that we can really make sure that the food that goes out to the market is very important. So I would rather advise that this project or this actual collaboration is something they are seeking to partner with the private stakeholders, and this is the time that the government would also have to play a role in it, to also make sure that the natural enemies they are promoting out there, the parasitoids, the fungus, and the nematodes would also be on a large scale.
Some farmers are eager to adopt the new technologies.
Because agri from Adaurma, more dear fat, a bearful, a quasso ama, and so you medium baby, anyway, no, and your pet.
Chimche, saying,
Habrono, stay, and one is a 190 man seno. And a sabu bakese. A brunabo boy, I in a crown, as I green, a habani green. It's what if with the medion say, the habana fitat is auntie, no sense to say will be baby or mudinum. And tea, some to me boy as I quite a crime, Mamuina, Monim Diana be the year, and a cababoy.
Quadrium, so I draw a branca say, a body I say, and I ask, say, first I draw the car bray, that's all the drone brayer. Ebetimi aboa ama oman yeso so ye di ehun ansan ka no akoba bibia ma ye hunu se hwe ehun mpanimfo no esu ehun nsem no mbaka kire ye no enye ntro ye di hu adanse se no kure pa enti abai ye pa wo chew ye sraw fedro no boa ye na ye nso so edwumadie no enkoso.
So with these innovative technologies, hopefully the burden of farmers can be alleviated. I hope you enjoyed today's discussion here on the food chain. Join me same time next week for another exciting episode. My name is Emmanuel Bright Kweku.